Let's talk about numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are called digits. Every number is made up of a combination of these 10 digits, 0 through 9. We're going to use these digits to make whole numbers. When we talk about the whole numbers, we're talking about 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. The ... means it goes this way forever. But the whole numbers start with 0, and then they are whole numbers, not half numbers, no fractions or decimals in between. Now, a digit's placement in a whole number determines its place value. So from right to left, we have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. So notice the pattern. Every 3 right to left, this something, tens, hundreds happens. Thousands, 10,000s, 100,000s. Millions, 10 millions, 100 millions. These are called periods, these groupings of 3. Let's take, for example, the number that's comprised of the digits 412716. The 6 is in the ones position. This 1 is in the tens position. This 7 is in the hundreds position. This 2 is in the thousands position. This 1 is in the 10,000s position. This 4 is in the 100,000s position. Let's get practice in determining position of a number. With these 3 examples. Our directions are to find the place value of the digit 4 in each whole number. So in A through C, you can see I've identified where our 4 is. And then I'm going to count the place values off from right to left. Ones, tens, hundreds, thousands, 10,000s. So this 4 is in the 10,000s place. has a place value of 10 thousandths. In part B, ones, tens. This 4 is in the tens spot. In C, ones, tens, hundreds, thousands, 10 thousands, 100 thousands, millions. This 4 is in the millions spot. When we have a number written out with digits, we say the number is in standard form. Now, remember, each of these is called a period. This would be the ones period. This would be the thousands period, the millions period. And that pattern from before, it continues. Thousands, 10 thousands, 100 thousands, millions, 10 millions, 100 millions. After that would come billions, 10 billions, 100 billions. And then trillions, 10 trillions, 100 trillions. So actually looking out at these periods, we'd have our ones period, then our thousands, then millions. And from here, there's a pattern. M, like mono, 1. Billions, by, 2. Trillions, try, 3. And then after that, quadrillions, quintillions. The pattern, bi, tri, quad, quint. That'll continue off as we go our periods in each one. 10,000, 100,000, million, 10 million, 100 million, billion, 10 billion, 100 billion, trillion, 10 trillion, 100 trillion. So why is this important? When we write this out in words or we go to say it, from left to right, just like we read, we're going to read the number of the period and then say the period's name. So our ones, thousands, millions, this is going to be billions. So 1 billion, 83 million, 664,500. So you could even think of this, the comma, as a reminder that you have to say the period name. 1 billion, 83 million. 664,500. Now, we don't usually say ones. We wouldn't say this is 664,500 ones. So when we get to this last part, we just say the number. Some practice. Here we have the number 36. When we write this out, or we write out any two-digit number, the two parts should be separated by a dash. So 36, 36, separated by a dash. In part B, 487. 487. The 87 has a dash in it. That's our two-digit number. Notice it's not 487. And is reserved for decimal points. We're not going to talk about decimals until much later in the course. So no word and. No. So here we have two periods, our ones period and our thousands period. This is 32,984. Not 984. We have our comma still separating the periods. And 32, 84, both of those have dashes because those are our two-digit numbers. Go ahead and write this one out in words. Take a little bit of time, write out this number. Okay. 321,670,200. We write this out. The 21. That's a two-digit number that we say. So we have to make sure we have the dash in there. After million and thousand, we still have our comma. And it's not 670, it's just 670. So 321,670,200. Now, notice if it was given in words, how would we put it in numbers? Well, before the word million is the number 321. We would write that down. 321 million, that tells us put in a comma. 670,000. 670,000 means put in a comma. 200, so number 200. So writing a number from words to standard form, just write the number in each period, followed by a comma. So 3 examples. 72. 906. And one that actually has 2 periods. 8,000, comma, 654. Let's talk about writing a whole number in expanded form now. So the expanded form of a number shows each digit of the number with its place value. So for instance, 5,672. This is what's written here. And it's not very visible for the camera, so I wrote it out bigger below. 5,672 is comprised of a 5, which has a place value of thousands. So 5,000. You could also get that by taking the 5 and replacing every digit to the right with 0. Then we're going to add to that the next digit, the 6. The 6 is in the hundreds spot. So we have 600s, 600. Or again, that's the 6 with 2 things after it that we're replacing with the 0. Then we have 7 tens. 70. 7 tens is 70. And then we have 2. 2 ones is just 2. So go ahead and we're going to write 804,557 in expanded form. To get you started, first, we have an 8 with 1, 2, 3, 4, 5 zeros after it. Or we can think of it as the 8 is in the 100,000 spot. So that's 800,000. And our next digit is 0. So we're not going to add anything just for that. We're going to move on to the 4, which is in the thousands spot. So we're adding to that 4,000. Go ahead and write out the rest of what expanded form would be here. So then we would have our 5. 5 hundreds is 500. And then 5 tens is 50. And then 7. So 800,000 plus 4,000 plus 500 plus 50 plus 7. I want to show another thing that this does. If we were to add these vertically and put in each of our numbers, notice that every column only has one number in it that's not a 0. So it's almost like the number just falls into place.
Today we're going to talk about rounding before we get into addition, subtraction, multiplication, division. And rounding's not bad at all. You probably already know how to do it, but we're going to go over it anyway. Let's start with a number like 242. And we're going to round to the nearest 10. So the rule is we find the tens place value. Ones, tens, hundreds. So we underline the tens spot. And then we look at the digit to the right. The digit to the right of the 10 spot, because we're doing nearest 10, that's going to be what determines if we round up or round down. A 5 or above in the spot to the right rounds up. A 0, 1, 2, 3, or 4 rounds down. So here we have less than a 5. So 242 goes to the nearest 10, which would be 240. Visually, what's happening here, what are the tens around 242? We would have 240. We would have 250. Visualize where 242 would be. It'd be closer to the 240. Literally, 240 is the nearest 10 to 242. Still nearest 10. Let's look at 585. Ones, tens. Look to the right. It's a 5 or above, so it rounds up. The 8 goes up to a 9, and everything else gets replaced by 0. So the 5, that's the one where if you visualize it, it would be right in the middle. If it's right in the middle, the rule is it goes up to the next one. 580, 590, 585 would be right in the middle. Let's do a nearest 100. For the number 8,189. Well, we find the hundreds spot. Ones, tens, hundreds. We look to the right. That's going to round this up to a 2, and everything after becomes a 0. This would be between 8,100 and 8,200, and we don't say that way. What did we learn last time? 8,100, 8,200. This would definitely be closer to 8,200. 8,200 is the nearest 100. Let's go back to another nearest 10. This time, let's see what happens when we have 498. Ones, tens is right here. If we look to the right, that 8 tells us we're rounding up. So what does the 9 become? To visualize that the 9 rounds up to 10, the 9 becomes a 0. That's the 0 from the 10. Where does the 1 go? Well, we're going to carry the 1. And when we look at addition later, we're going to do a lot of work with carrying the 1, carrying the 2. It's more than just a joke you hear when you're watching a movie and someone's doing math in their head and all you hear them do is mumble, carry the 1. We're going to do all that stuff today. So the 9 rounds up to a 10 expressed by the 0 here. And then we add 1 to the 4. So it rounds up to 500. And again, this makes sense. What are the 10s around 498? 490 and 500. And it's definitely closer to 500. 500 is the nearest 10. How about 72,369? This one to the nearest 1,000. Just because it's now the nearest 1,000 doesn't mean we do anything different. Find and identify the thousands spot. Ones, tens, hundreds, thousands. Look to the right. Is it a 5 or above? No. So it rounds down. The 2 stays a 2. It doesn't drop down to 1. Rounding down is called that because the 369 comes down to 0, 0, 0. Again, what are the nearest, or what are the thousands to the left and the right? We would have 72,000. We would have 73,000. And this, because it's under 72.5, is closer to 72,000. 72,000 would be the nearest 1,000. Okay, so we can round any place value we have. Tens, hundreds, thousands. And we're going to come back and look at rounding a little bit more after we do addition and subtraction, because we're going to use rounding to estimate some answers. The last rounding problem we are going to do together, though, $79,991. Let's round it to the nearest 100. So if we're rounding it to the nearest 100, tens, or ones, tens, hundreds. Look to the right. It's a 9, which is going to bump this up. But since that's a 9, it's going to bump that up. And since that's a 9, it's going to bump that up. That becomes an 8, and everything else got bumped up to 0, and then these ones become 0. If we were rounding to the nearest 1,000. Ones, tens, hundreds, thousands. Look to the right. Rounds this up to 10. That becomes an 8. Same answer. To the nearest 10,000. This rounds up. Same answer. What about to the nearest 10? Ones, tens. That one would not round up. Nearest 10. Would be 79,990, which again is not how we say that number. 79,990, not 79,990. And is going to be reserved for speaking decimal names, something that we're going to do down the line. Next up, let's look at addition. We have 16 plus 32. Our rules for doing addition by hand, because there's no calculators allowed in this class, is that we line up the numbers so that they all end in the same spot. And then we look at one column at a time, starting with all the way on the right. What's 6 plus 2? Do it on your fingers if you have to. 6 plus 2, 7, 8. Move to the next column. What's 1 plus 3? 1, 2, 3, 4. Added 3 to the 1, 4. So the answer here would be 48. When we add two numbers, our answer is called a sum. So let's find the sum of some other numbers. I don't know, that wasn't that great. We're adding 60 and 628. Again, we make sure that they end in the same spot, not begin in the same spot, end in the same spot. One column at a time. What's 0 plus 8? Well, anything plus 0 is itself, because adding 0 does not change anything. 6 plus 2, 6, 7, 8. Empty spot plus 6. Well, when we see an empty spot, treat it like a 0. 0 plus 6 is itself 6. So 688. Not too bad there. But what if I'm adding 3 numbers? Well, the way we would write it is like this. We wouldn't put 2 plus signs. We just make our column of numbers that are going to be added together, and we put just one single plus sign. Same rules though, one column at a time. So what's the sum of 1, 2, and 3? 1 plus 2 is 3, plus 3 is 6. Next column. 1, 2, and 4. 1 plus 2 is 3, plus 4 is 7. So 76. I'm going to throw a wrench into things now. Nothing major. It's just that I'm going to give you the problem like this. Across 45 plus 64. When we see addition written horizontally, don't try to do the work this way. How did we just learn how to do it? Columns. So write it in a column. 5 plus 4 is 9. I'm not hiding with the eraser anymore. One column at a time. 4 plus 6 is 10. This is the first time we've gotten something that's above 9. And since there's nothing that we're interfering with, we're actually able to write the entire 10 in there, just like that. 109 is the answer. Another one. Let's look at 45 plus 790. So you could write this one of two ways. If you keep it in this order, 45 plus, you have to make sure it ends in the same spot. So the 0 would go here, the 9 would go here, the 7 would go there. And add down, throwing another wrench into this one. Let's bring the columns back. high eraser. 5 plus 0 is 5. No issues. Moving on, 4 plus 9, 9, 10, 11, 12, 13. We can fit the 3 in the column, but there's other stuff in this column. We can't just put a 1 here. There's more to add. So what do we do with the 1? Just like those people mumbling math in movies, we are going to carry the 1. So 4 plus 9 is 13. There's the 1, there's the 3. 13. And now we have another number in our next column. We would add the 1 and the 7 to get 8. Okay. Let's do some more work with carrying. Let's look at, and maybe I have a nicer marker somewhere. Let's look at 30,770 plus 490,934. So with addition, not subtraction, just addition, you're able to add the numbers in any order. 2 plus 3 is 5. 3 plus 2 is 5. So if you see this number is bigger than this one in terms of having more digits, this has 6 of them, this has 5 of them. And if you want to write the 490,934 first and the 30,770 second, so that it looks more appealing and you can put the plus sign in. It's nice and compact. You're more than welcome to write it that way. Because it's addition, you don't have to put the first thing first and the second thing second. You can write them either way. So I'm going to tend to start writing them this way when I'm translating from horizontal single line to vertical. And how do we do this? We're going to do it one column at a time. 4 plus 0 is 4. 3 plus 7 is 10. Split it, carry the 1. The 0 goes down here. The 1 goes up here. 1 plus 9 is 10 plus 7 is 17. Put the 7 down here. We're carrying a 1 again. 1 plus 0 is just 1. 9 plus 3 is 12. 9, 10, 11, 12. Put the 2 down, carry the 1, and 1 plus 4 is 5. We put our comma in. Our answer, 521,704. Nine plus 4 plus 1 plus 7 plus 6. So you can go straight down. 9 plus 4 would be 13, plus 1 would be 14, plus 7 would be 21, plus 6 would be 27. But when we have a large group like this, there is a quicker mental way that doesn't have you adding those weird numbers. I don't know about you, but I always used to struggle with my 7 and my 6 and with my 8 and my 7. I just couldn't get it to click in my head quickly enough that 6 plus 7 is 13, that 7 plus 8 is 15. Even now, as I said that, I had to be careful and make sure that that was right. So what's 5 plus 5? That's 10. What's 6 plus 4? That's 10. What's 7 plus 3? That's 10. We tend to recognize things that add to 10 more easily. 9 and 1 is 10. 4 and 6 is 10. And then we have 7 left over. 10 plus 10 is 20, plus 7 is 27. So when we're adding, when it's all addition, just like we don't have to add them in the order they're given, we can switch it around. We could also add around in the list. It's like switching the order to be the way we want it. We can group and add in any order as long as we end up covering all the numbers. Let's do another one like that. Let's add this list of 5, 28, 41, 59, 72, and 15. And we are adding. So you can go straight down the list like I showed originally, but we could also find some groupings of 10. 8 plus 2 is 10. 1 plus 9 is 10. 10 plus 10 is 20, and here's this extra 5. 25, we'll put the 5 down and carry the 2. Number 25 literally gets ripped apart. Four, 5, and 1 make 10. 7 and 2 would be another 9. And 2 would be 11, plus that 10 would be 21. This row with our carried 2, it didn't really have any nice combinations like that. So if you just wanted to go 2 plus 2 is 4, plus 4 is 8, plus 5 is 13, plus 7 is 20, plus 1 is 21. That'll get you there too. Okay. Right now I'm looking through the homework assignment, making sure that I'm covering everything that you'll need to work. I do want to move on to our next topic. But looking through this, there are plenty more questions where you can practice addition. This one I'm looking at here is 2 digits plus 3 digits plus 4 digits plus 5 digits. So there is so much practice in the homework that you're going to be doing just on adding numbers by hand. You're going to hate it. What did I say that the answer was called when we added 2 numbers? I said it was a sum. So the first maybe kind of word problem that you're going to encounter in the course is just going to simply say, find the sum of 4,796 and 299. It's going to be a find the sum of problem. But we know the sum is just what we call the answer when we add. So how do we find the sum? It's just telling us to add 4,796 plus 299. Six plus 9 is 15. Rip that apart, put down the 5 and carry the 1. 1 plus 9 is 10, plus 9 is 19. Rip that apart, put down the 9, carry the 1. 1 and 7 is 8, plus 2 is 10. Rip it apart, put down the 0. carry the 1. 1 plus 4 is 5. 5,095 would be the answer here. Finding the total of is another way of saying add. What is one number increased by another? I don't know, but you know how you can find out? Add. And of course, you can see the word plus written out as well. Okay. That's addition. Let's talk about subtraction. We're going to line things up the same way we did for addition, but instead of plussing, we are going to minus. 6 minus 1, 6 take away 1 would be 5. We're doing the columns same way. 9 minus 6 would be 3. You could use your fingers here too. 6 take away 1 is 5. 9 take away 1, 2, 3, 4, 5, 6 is 3. Subtracting is literally taking away. That's why you might have heard people say take away instead of minus. And as long as the top number in every column is bigger than the bottom number, we don't have to worry about the subtraction equivalent of carrying, which is called borrowing. And that makes sense. If addition has you give something to the next column, I guess you'll see me this way, give something to the next column. Oh, I was right the first time. Next column will show up this way. Nope, this way. And now I'm accidentally hula dancing. So enough of that. 9 minus 7 is 2. 7 minus 5 is 2. 9 minus 4 is 5. Notice 9 bigger than 7, 7 bigger than 5, 9 bigger than 4. We like the subtraction problem when when the numbers on top are bigger than the numbers on the bottom. Let's do a few more. $178 minus 34. 8 minus 4 is 4. 7 minus 3 is 4. 1 minus nothing because there's nothing there is still 1. Wrench. I'm going to give it in one single line. Solution. You're just going to write it vertically. That was the only wrench because everything on the top is bigger than what's on the bottom. This is easy. 9 minus 4 is 5. 9 minus 3 is 6. 4 minus 3 is 1. 5 minus nothing is 5. I apologize if you hear the sound of that outside. Someone is doing yard work and there's nothing I can do about it. I'm so sorry. 7888 minus 3553, and we know we don't say those numbers like that. 7,888, 3,553. Write it vertically. And no issues. 8 minus 3 is 5. 8 minus 5 is 3. 8 minus 5 is 3. 7 minus 3 is 4. Now, when we subtract, we have the ability to check by adding. Because if this minus this is that, if we add this back to that, we should get what we started with. So if you don't want to run the risk of this being the wrong answer, you're always able to check by adding. So take the result you got and add back the thing you took away. 3, 5, 5, 3. And if we add, we get 8, 8, 8, 7, which is what we started with. The fact that we checked by adding and got what we started with means that we know before we're even graded 100% we were right. So let's check by adding on this next one as well. 695 minus 395. 5 minus 5 is 0. 9 minus 9 is 0. 6 minus 3 is 3. Are we right? How can we be sure we're right? We can check by adding. So we can take the 300 and we can add back what we took away, the 395. 0 plus 5 is 5, 0 plus 9 is 9, 3 plus 3 is 6, and 695 is what we started with. So we know we are correct. Wrench. 62 minus 43. 2 minus 3 is, the number on the top isn't bigger than the one at the bottom anymore. 2 minus 3, that would be a negative number. We can't just use our digits, our 0 through 9. So what we're going to do is we're going to borrow from the 6. We're going to strike down the 6 to a 5. And what are we going to do with this extra 1? We're going to shove it onto the 2. So the 6 goes down to a 5 and the 2 becomes a 12. We lost 110 here and we added a 10 to the 2. 12 minus 3, now that is 9. And 5 minus 4 is 1. I don't know. We should check this by adding because that was something new. Maybe we did it wrong. And when we add our potential answer of 19 plus the 43 that we took away, notice that this problem is going to have carrying because when the subtraction problem has borrowing, the addition problem will have carrying. 9 plus 3 is 12. Split that apart, carry the 1. 1 plus 1 is 2, plus 4 is 6. 62 was the original answer. Let's keep up with the borrowing. And let's look at 90 minus 75. So 0 minus 5 we can't do. Top number is smaller than the bottom. We like when it's bigger minus smaller. So we have to take 1 away from the 9, lowering it to an 8. And that 1 that we took turns that 0 into a 10. The 1 just gets shoved up against it. 10 minus 5 is 5. 8 minus 7 is 1. And we can check by adding 15 plus 75. Carry the 1. 9. So that's right. More digits. 717 minus 553. First column, we're okay. 7 minus 3 is 4. Second column, we're not okay. 1 minus 5. So we borrow 1 from over here, lower that 7 to a 6. Shove that one we took right up against that one, so it's 11. 11 minus 5 is 6. And then 6 minus 5 is 1. 164. So the next wrench is going to come in when we borrow from a 0, something that happens in this problem. 800 minus 557. Okay, so 0 minus 7, we can't do it. Normally, we would take 1 away from what's to the left, but it's already a 0. We can't take 1 away from that. So here's how I like to explain it. When we have to borrow, but it's a 0, we jump over all the zeros, and any 0 we jumped over becomes a 9. What we jumped over to is what we borrow from, so the 8 becomes a 7. And since we borrowed that 1, it ends up over here, turning that original 0 into a 10. 10 minus 7 is 3. 9 minus 5 is 4. 7 minus 5 is 2. I'm going to show this again. But next, to kind of try to help you understand why this worked, I'm going to write the same problem, but I'm going to leave myself more room in between the numbers so that I can give you more of a sense of what's happening behind the scenes and why the jump over turned a 9 trick works. We need to borrow to turn this into something. Normally we would borrow from here, but we don't have anything to borrow from. So we need to turn this into something to borrow from, which means we want to turn this into a 10, and we can do that by borrowing from the 8. And now, since this is 10, we can borrow. So we take 1 away from the 10 and it becomes a 9, and that 1 goes here. 10 minus 7 is 3. 9 minus 5 is 4. 7 minus 5 is 2. So the outcome is that this turned into a 10 like we wanted. The thing we jumped over, the 0 that we jumped over, became a 9. We actually borrowed from here, which became a 7, turning this into a 10. So like I said, I'd show it again without all that stuff explained, but now hopefully you see why we do the things we do here. We're borrowing from the 8, it becomes a 7. We jumped over this 0, so it's a 9, and that's a 10. 3, 4, 2. Let's do more with this. Looking for a good one in the homework. 300 minus 282. We need to borrow. We can't borrow from the 0, so we skip over it. We borrow from the 3. Turns the 3 into a 2. This becomes a 10 like we want, and the 0 we jumped over becomes a 9. 10 minus 2 is 8. Yep, I got dogs. Not my dogs. I got dogs on the street barking all day. So annoying. And they stopped. Oh, great. 10 minus 2 is 8. 9 minus 8 is 1. 2 minus 2 is nothing. So we don't write any number there. 0, 1, 8 is not how we write 18. We know how to write 18. 18. Okay. $50,000 minus $25,387. So I wrote it long ways. What's the first thing we do? write it vertically, write it up and down. We are subtracting. Right off the bat, we need to borrow. We want to turn this into a 10. We got to skip all these zeros. We turn that into a 10, we actually borrow from the 5. That becomes a 4. What do we do with all the zeros that we skipped over? Not the one that we turned into a 10, but the actual 3 that we skipped over, they turn into 9s. 10 minus 7 is 3. 9 minus 8 is 1. 9 minus 3 is 6. 9 minus 5 is 4. 4 minus 2 is 2. Let's check this one by adding. Let's do 24,613 plus 25,387. 3 plus 7 is 0, carry the 1. 1 plus 1 is 2 plus 8. That's 10, carry the 1. 1 plus 6 is 7 plus 3, that's 10, carry the 1. 1 plus 4 is 5, plus 5 is 10, carry the 1. 1 plus 2 is 3, plus 2 is 5, 50,000 is correct. Okay. What about when the zeros aren't all in a row? Does that make the problem easier, harder? Let's find out. 7,030 minus 1,868. Write it vertically. Zero minus 8, we can't do it. We got to borrow. Turn this into a 2. That's a 10 now, though. 10 minus 8 is 2. 2 minus 6, we can't do. We got to borrow. Can't borrow from the 0, so we hop over it. That 0 becomes a 9. The 7 will come down to a 6. And now we've turned our 2 into a 12. Subtraction, right? So we did 10 minus 8 is 2. Now we have 12 minus 6 is 6. 9 minus 8 is 1. And 6 minus 1 is 5. 5,162. Okay, remember when we were doing addition, I said you might see a word problem like the sum of. Well, we got some base level subtraction word problems now. Let's talk about what we would do if it said subtract 2 from 5. Unlike adding, where the numbers can be put in any order, so you don't have to be careful, subtracting cannot be put in any order. You do have to be careful. For instance, 3 minus 2 is 1, but is 2 minus 3 1? No, it's negative 1. Spoiler alert, we're not going to know that until the end of class. The point is, the end of the course, not the end of today. The point is that 2 minus 5 would be different from 5 minus 2. So we need to figure out which one this wants us to do. And the wording is going to tell us. We have to be careful. This is where this math class kind of turns into an English class. If we are subtracting 2 from 5, we need to understand the English language well enough to realize that this is saying we are starting with 5 and we are subtracting 2 from the 5. So we're starting with the 5, and from 5, we subtract 2. This would be 3. And just like a sum is the answer of an addition problem, the answer to a subtraction problem is called a difference. So when you subtract 2 from 5, you get a difference of 3. Speaking of the word difference, just like a problem would say find the sum of, now we're going to say find the difference of 30 and 21. Subtracting has to be in the specific order. So you have to understand what it's asking. This one, we actually keep them in the order they're given. When we see difference of blank and blank, that is a subtraction, and you keep it in the order that it was given. So the difference of 30 and 21 is 30 minus 21. Another way of asking this same problem would be, what is 21 subtracted from 30? 30 minus 21, which will set up vertically. 0 minus 1. Well, notice I put a 9 right away. 30 minus 21, that'll come to you. And if we want to show the work we're doing here and keep it consistent with what we did before, 0 minus 1 we can't do. So we borrow from the 3, turning it into a 2. Now this 0 is a 10. 10 minus 1 is 9. 2 minus 2 is nothing. So the difference is 9. Another weird way of seeing a subtraction problem. Find 106 less 53. This does not say find the number that is 106 less than 53, which would be some negative number. 106 less 53 means we start with 106 and we make it less 53. In other words, what's this number if there were 53 less? If we subtracted 53. So less is another one like the difference of blank and blank, where we keep them in the order given. 6 minus 3 is 3. 0 minus 5, just bring that 1 over. 10 minus 5 is 5. So it is 53. Check by adding. 53 plus 53, 106, we're good. What's the key word in this one? Find 44 subtracted from 100. If you had to pick a word that was the most important word here, you might want to say subtracted. But if there was a different word that's the most important word here, not a lot of words left. From. Subtracting from 100 means we have started with 100, and from that we are subtracting 44. $56. Okay, going through just to make sure we've done all the different product types of subtraction, and we have. I'm going to go ahead and take a look at an estimating problem. If we had 61, 86, 26, and 74, and we were adding them all together. Remember, this, we could add the 6 and the 4 and get 10, 11, plus 6 would be 17. Carry the 1. Wow, this is so detailed. So many numbers. 1 and 6 is 7, plus 8 is 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 247. What if you didn't need the exact answer? What if you just wanted an estimate? Well, we can estimate the sum and not find the answer if we only need an estimate. So if it says estimate, it'll give you some additional information. Estimate the sum. Let's do it by rounding each number to the nearest 10. So the nearest 10, we'd be looking at the ones spot to determine if it rounds up or down. 61 would round down. 86 would round up. 26 would round up. 74 would round down. Add a bunch of zeros, you get 0. 6 plus 9 is 15. 16, 17, 18, 19, 20, 25. And what was, I erased it and I don't remember, so I'm going to cheat. Don't tell the teacher. 247 is the exact answer. So that's darn close. And that's what you want an estimate to be. You want it to be darn close. If you go to an auto shop and you ask for an estimate on your car and they say it's 250 and it ends up being 247, good deal. That's an estimate. That's what you want. You don't want them to say it's going to be 250 and then actually charge you 793. That's not a good estimate. So good estimate is close to the exact answer. We can estimate with subtraction. And since subtraction has all that weird borrowing stuff in it, this, again, I'm going to cheat because we don't want the actual one here. The answer here is 75. Let's estimate by rounding everything to the nearest 10. This would round up. That would round down. 5 minus 7 can't do it. 15 minus 7 is 8. Very close. In fact, it's good to the nearest 10. Can't get much better of an estimate to the nearest 10 than actually getting it to the nearest 10. So you'll have some estimation problems. And I want to make this clear. If it's just a subtraction problem, you can't just decide you want to estimate. The problem actually has to say estimate. But it'll tell you whether to round things to the nearest 10, to the nearest 100, maybe to the nearest 1,000, depending on how big the numbers are, in order for you to get an estimated sum. So estimating is just rounding and then adding or subtracting. It makes the numbers a little bit easier to deal with in situations where you don't need the exact answer. So the first two rules of multiplication that you're going to learn today, they are the most important. When we have 1 times a number, the answer is always itself. Multiplying by 1 does not change the value. One way of expressing multiplication, which you've probably seen as the times sign, the X. What we like to use is the dot. The dot also means times, means multiply. If we had 1 times 93, that would be 93, because anything times 1 is itself. Second major rule, 0 times anything, it doesn't matter what it is, 0 times 85 is 0. So 1 times a number is that number. 0 times a number is 0. This is one of the most important rules you're going to come across later on in algebra as well. The fact that 2 things multiplied together giving you 0 means that one of the numbers is 0. That proves very useful. And just like addition, we can multiply in any order. Because of that, if we have a string of things multiplied together, 9, 0, 2, 1, 0, sorry, 9 times 0 times 2, as long as one of the digits in that chain of multiplication somewhere is a 0, we know the answer is going to be 0. Why? Because if we go along left to right, eventually we're going to get 0. 9 times 0 is 0. And now 0 times whatever is going to be 0 times whatever is going to be 0 times whatever is going to be 0. So as long as there's 1 0 in the multiplication chain, the answer is going to be 0. Think fast. 80 times 1 is 80. Anything times 1 is itself. I'm talking about the distributive property. If we have something like this, 6 times 8 plus 3, we can take what is on the outside, and when we have a number right up against a parenthesis like that, that means multiplication. Surprise, in the multiplication section, we have multiplication. But since there's a sum inside, since there's more than one thing being added or subtracted, what we do is we multiply this number on the outside times the first, times the second, and then keep whatever sign that is in between. So using the distributive property, here distributing the 6, we can rewrite this in another form. We're not going to simplify that form. Okay? 6 times 8 plus 6 times 3. The distributive property says these are equal. So when we rewrite this using the distributive property, this is the answer that is required, not worked out. Unless it actually says find the answer, if it just says rewrite, that's what we need to see. What is the answer, by the way? 6 times 8 would be 48, plus 6 times 3 would be 18. 8 plus 8 is 16. Carry the 1. 1 plus 4 is 5, plus 1 is 6. The answer is 66. Notice here, 8 plus 3 would be 11. 11 times 6 will also be 66. So they are, in fact, two equal forms. But right now, since we actually haven't talked about any multiplication outside of 0 and 1, this is all we're doing with the distributive property. We're just rewriting it from this form to this form. Excuse me. If we have 5 times, in parentheses, 7 plus 4, we can rewrite this as 5 times 7 plus 5 times 4. Twelve times 20 plus 21. 12 times 20 plus 12 times 21.